In this video, I will attempt to show you how I wired up a Popperette for my buddy. Hopefully he'll be able to follow this video and then he can do it for himself, so I don't have to do these anymore. But yeah, as my disclaimer, I am not an electrician, so do not try this at home. Alright, first off, I'm just gonna use this line to represent where the plug is. We're gonna just call this, just to make it easier, just call this the hot. We'll call it the common. I'm gonna make all the hot wires are gonna be black and all the common wires are gonna be white. First thing I want to do is we're gonna just go from the plug. We're gonna go to a fuse. Okay, it's gonna go off the fuse to a terminal. I don't know what we'll call that yet, but we'll call it something. Usually 1, 2, 3 A, B, C or something like that. Anyway, then it's going to go to a light. It's going to come off the light to another terminal, and then it's going to end up at the neutral part of the cord. And this line here basically is going to be powered all the time. Another one that's going to be powered all the time would be the coin reject coil, which would just come off right here in parallel. Just draw the coil and we'll just come back down right over here. So that's the first two I'm going to show you. The purpose of the coin reject coil is if the machine is turned off, and just say this was on location somewhere, and you put a dime in, it will reject it out here because there is no power to it. Okay, now if you, I just get this off here. These are always fun. If you look back here, here's the coil. Now once it's energized, it's going to pull this in, and then the coin, as you can see right here, the coin's going to fall through here and be accepted. Where before it was on this side, it was being rejected because it was hitting this. Once this pulls in, it's good to go. One thing I forgot to mention was you should check all your coils, your motor, and any of your loads just with an ohmmeter, just to make sure that they're good before you even attempt to solder them or put them in. That's just normal practice. But with this one, what I want to do is, because this is behind a metallic rejector, and if someone's taking this off, because this is a hot all the time, so if it was plugged in, someone's taking off and they accidentally hit this, they're going to get zapped. So good practice would be to get some shrink tube, slide it over here and heat it up, just for precaution. And you might want to do it on any other areas where you think, actually just do it on everything. Better safe than sorry. I just wanted to show the coil after I finished putting the shrink tube on there. There was a little exposed area, so I had to use some of that liquid tape on there. Then you just take your needle nose pliers and you bend the wires up, and then you come up on top and you go across through here, and that's where the light bulb is on the other side, and that's where we're gonna make our connection. Okay, I was gonna put the cord on, but I noticed that it's 18 gauge wire, which is good for like 7 amps. I'm not sure the amperage draw on the Popperette, but I really don't think it's going to be much more than 10, so I don't really want to use this. The wire that I'm using is 14 gauge, which is good for 15 amps. So anyway, I'll just briefly show you how this would work. You would have your hot wire going to this side of the fuse, your ground would be over here, and then your common would go through a porcelain insulator coming through to this line right here. Okay, what we have so far is, if we had that, here's your fuse. So you have your fuse, then we're going to terminal, I just named it 1 because you have 1, 2, 3. So it goes to terminal 1 from here through here, then from 1 to the light, so that's this going, can you see that? Going to the light, so that'll be right there. And then it comes out of the load, so now it's becoming a common or neutral, and this is going to terminal 3, and then out of 3 it would have went back to the cord. And then your other circuit is your coin reject coil, which you already seen on the other side, but I have that wired parallel coming off your light socket and feeding back over here. So basically you got your hot, which is on this side, going to the coil. Coming out of the coil is neutral, coming back here. All the screws, I use the spade connectors, the forks I should say, the fork connectors. And over here, a nice tip is, because you don't know how many wires you're going to end up with here. If you put it like that, it's going to pop off. So I just put the ring ones on, and then just give it a little crank. Well, before that, all your connectors, make sure that they're crimped and you pull on them. Make sure that they're all tight. And all your connections, I want you to make sure they're really tight, because if you have any loose screws, you're going to draw higher amps there, and you're going to cook the wire or damage the part. And so far, that's basically your coin reject coil and your lighting circuit there. Alright, the next circuit we're going to do is for the heater. So we're going to come off this terminal to the heater switch, which is normally open, and then we're going to go to the heater, and then it's going to come back here and just go to that terminal. So this is your heater, and this is a heater switch. We just finished wiring in the heater circuit. We got it coming off of terminal 1. It goes to a normally open heater switch. Then comes out of the heater switch to the heater. There's these like lightning bolt looking pieces of metal that are attached up here. And then they go to your actual heater. Then it comes out of the heater, comes back up here and goes through to your common. What I used was I use like a heat resistant wire. It's got like Teflon and some form of heat resistant cloth on here, but not asbestos, but it's whatever the new stuff is, because this area gets a little hot, so I just kept like that. But basically, if you zoom in over here, this is what we did. We went from terminal 1 to the switch, out of the switch to the heater, out of the heater, now it goes to the common, to terminal 3. In case you use coconut oil, that's what this machine originally had, you need an additional heater just to melt the oil, because coconut oil is a solid at like 72 degrees. Anything above that, it starts melting. So just call this oil heater or something. Call it what you want. And that's what this is here. Basically, it's just a porcelain piece with a heater underneath it. This gets hot, and you put it in your oil. It can be submerged in oil with a contact like that, but you don't want it in a metal pan for obvious reasons. I use a glass bowl, and that's just wired the same thing. You just got coming off of 1 to the heater, and then from the heater to 3, and that's just if you use coconut oil. If you use regular corn oil, you don't need this. But the only problem with corn oil, sunflower oil, or any of the other oils, vegetable oil, this whole thing gets gummed up. Your heater gets gummed up, your front gets gummed up, and it's really a pain to clean. Coconut oil is very clean. You could just clean it up with a damp warm rag. So I would recommend that. Actually, I would recommend 2 of these. Or what I've had problems with is the oil up here not melting. So I put a rope heater on mine. Came up here, and then this is just for the oil. If you have 2 of them, you can make popcorn in like 5 minutes. With 1, probably be about 30 minutes before the oil's melted enough to get up here, because you don't want to run the pump dry, and you have to have oil return get into the heater, because if the oil doesn't get pumped, let me turn this here. If the oil doesn't get pumped coming up here, through here, filling up this, there's a cooking chamber. If it doesn't fill this up, this heater will crack, and that's like the heart of the machine. So you want to make sure that you have liquid oil going through at all times.